Section 4.4, we're finally going to officially talk about the natural log in this section. All right, so we talked about it, we came up a little bit before, but here we are. So the natural log is a log where the base is e, and it is written as ln of x. Okay, so again, that is ln of x. All right, that's not an I, it's L for log. Okay, so so to simplify ln of e squared, so we know that ln is the same thing as log base e. So log base e of e squared. So then you could just cancel out log base e with e, and your final answer would be the 2. Okay. All right, so number 2, again, so ln is the same thing as log base e. All right, and the cubed root of e, so we want to write that as e to an exponent. So the cubed root is the same as the power of 1/3. All right, so then we could cancel out log base e with e, and our final answer for that would be 1/3. All right. And let's see, e to the power of ln of x to the 5th. So again, we know that ln is the same thing as log base e. So that would be like e to the power of log base e of x to the 5th power. So we would just cancel out the e with the log base e, and our final answer would be x to the 5th power. All right, so number 4, it just says log of 0.001. So the base is understood to be 10. Okay, so it's log base 10. And we want to rewrite this as 10 to a power. Okay, so that's the tenths, hundredths, thousandths. So that's the same thing as 1 over 1,000. Okay. So 1,000 is the same thing as 10 to the 3rd power. So that's 1 over 10 to the 3rd power. And so 1 over 10 to the 3rd power would be the same thing as 10 to the power of -3. And then we can cancel that out, and our final answer would be -3. All right. So number 5 says g of x equals e to the x. So part A, we want to evaluate g of ln of 9. All right, so it's e to the power of ln of 9. And we know that ln is the same thing as log base e. We don't necessarily have to rewrite it in that way. We just know that those cancel out, and so the answer would be 9. All right. And let's see, part B says g of ln of 1 over e to the 8th power. Okay, so that would be e to the power of ln of 1 over e to the 8th power. And then we would just cancel out this e with this ln, and our final answer could be 1 over e to the 8th power. All right, and then number 6, f of x equals ln of x. Part A, we want to evaluate f of the square root of e, so that would equal ln of the square root of e. All right, and so we want to rewrite the square root of e as e to the power of 1/2. And then we are able to cancel out the ln with the e, and our final answer is 1/2. And part B, so it's going to be ln of e to the power of 3 ln of 4, and then we can just cancel out that ln with the e, and our final answer is 3 ln of 4. All right, number 7, 3 ln of 2y equals 4 ln of x. All right, so the first thing I'm going to do is take the coefficient and move that, make it an exponent on both of these. All right, so that would give me ln of 2y to the 3rd power. And I do need to have that 2y in parentheses with the exponent on the outside because it's got to apply to that whole thing of 2y. All right, minus ln of x to the 4th power. So now I can combine these into one log. So that would be ln, I don't like how that looks, ln, and it's going to be a fraction because it's a subtraction, so it's going to be ln of, and I should probably go ahead and distribute that. So 2 to the 3rd power is 8, and then y cubed over x to the 4th. So ln of 8y cubed over x to the 4th would be the answer. All right. All right, and then next we will talk about the change of base formula. All right. So the reason why the change of base formula is important typically is because you can use it with a calculator. Most scientific calculators only have the common log and the natural log on the calculator, and so if you want to evaluate a log that has a base other than that, you would use this to do that. And so we typically don't really use calculators in this course, so we won't be using it in that way. But that is a primary purpose of what it's used for. So anyways, the change of base formula, so log base b of a is equal to log base m of a over log base m of b. So the m can be whatever base you want. So like I was saying, most of the time it's either going to be a common log, so that could be log of a over log of b, or a lot of times you'll want to do a natural log, in which case that would be ln of a over ln of b. And so you might see on your MyLabs Plus homework that they might give you something where they'll say to write your answer in terms of common logs or natural logs, and so in that case that might be a situation where you would need to use the change of base formula. Okay, so number 8 says if log base x of 5 equals 8 and log base x of 7 equals 9, then log base 5 of 7 equals what? Okay, so log base 5 of 7, so if you use the change of base formula, that would equal, so it's the log of the argument over the log of the base, and the base here that they gave us is x, so I'm going to say that's equal to log base x of 7 over log base x of 5. And then they told us that log base x of 7 is 9 and log base x of 5 is 8. So 9 over 8 would be the answer. And then log base 7 of 5, so that would be log base x of 5 over log base x of 7. So that would equal 8 over 9. All right. Number 9 says if log base y of 12 equals 3 and log base y of 20 equals 18, then we want to evaluate log base 12 of 20. Okay, so log base 12 of 20 using the change of base formula and using the base of y to change it into. So that would be log base y of 20 over log base y of 12. And then using the information they gave us, that would be 18 over 3, which is equal to 6. And log base 20 of 12 would be log base y of 12 over log base y of 20, which would equal 3 over 18, which would reduce to 1/6. Okay. All right, and that's the end of 4.4.